Hello again. Let's move on to the next topic, which is the interworking. And before we have the other interworking sessions after this, like the Zigbee interworking and LoRa interworking, I will be giving you a brief introduction to the interworking in general, defined by oneM2M. So as the motivation for this session, from day one, as the oneM2M overview, I highlighted release 1, 2, 3, and in release 2, the main focus was the interworking to the other technologies like the OCF and the lightweight M2M and 3PP. And in this tutorial or the session, we are going to kind of provide some information how non-on-M systems or technologies can be worked together with one M2M. So you can uh, have some kind of leverages on those different systems with your one M2M. So there are different oneM2M interworkings in oneM2M specifications. So we will set a scope, and then we will learn about basics of IPE. I will explain what it is IPE really soon, and we will have some kind of sample or simple recipe that could be the backbone for the LoRa interworking and beyond interworking or the other interworkings for your applications later. Firstly, the different types of interworking from oneM2M. So on the right hand side, this is the screen capture for the release 3 specifications, and I was looking for the keyword interworking. And there are different interworking specifications like the lightweight M2M, OCF, 3PP, ontology, and the interworking framework, and OSJ interworking, and so on. So there are different or many interworking specifications, and sometimes some are in still the kind of study phase, like the technical report, rather than technical specification. Anyways, the point is there are a lot of interworkings specified in oneM2M. And let's gonna narrow down the scope of interworking that we are going to have some practice today. And the first thing, which is not the scope, is the kind of 3PP like interworking. And this is one of the diagram from the function architecture, which is 0001. And yeah, so let's remind what it is. This is application entity, which is basically the one application, CSC, one platform, and network services entity, basically the network server side API server. And the thing for the 3PP networking is like this. So there is the API server from the core network, for example, from the mobile operator, and that is connected with the oneM2M platform. So in the end, oneM2M applications can access to those functions via oneM2M platform and get there. So that's the kind of 3PP interworking or MCN based interworking. Okay. MCN stands for the reference point for the kind of reference point between CSE and NSE. And the APIs that we've been looking at from yesterday, like the content instance creation or the other, they are normally for the MCA between the oneM2M application and to the CSE, and also for the other reference points like CSE to CSE. The other interworkings like the OCF interworking and lightweight M2 interworking, they are mostly for the MCA because from oneM2M point of view, especially the oneM2M platform's point of view, the other systems can be seen as oneM2M applications, and maybe the other system in general or the proxy entity between the other system and oneM2M system, there will be the oneM2M application which works as the proxy. So from oneM2M platform side, they are all oneM2M applications. So this is the kind of And in the specification, there's the other kind of diagrams which explains the concept. So again, IP stands for the interworking proxy entity or interworking proxy application entity. Because even we say IPE, but that is one type of oneM2M application like the AE, but it has a special purpose like the interworking in the non-oneM2M and oneM2M system. So we have the definition in the specification. So IP is a basically the bridge between those two words, and IP represents the one non-oneM2M system to oneM2M system. And as I've been saying, in oneM2M, especially oneM2M platform, everything is exposed or represented as resources. Data as container instance container, or the functions like the group or subscription and the other. Everything is a resource. That means the other system like the OCF kind of system deployment or like the M2M, their device and service or data, they are all going to be exposed or represented as one M2M resources. And that's why we've been kind of learning or trying the one M2M APIs that are REST resources, REST APIs. That's the basic idea. So IPE is the interworking proxy entity which bridges the other two words, non-oneM2M and oneM2M. So what is the basics or the essence? So this is a diagram which I extended a little bit from the day one in the application developer guide. And in that session yesterday, the devices were the oneM2M compliant devices. That was the assumption. And in this case, those are non-oneM2M devices. So to use them from the oneM2M platform and especially from the oneM2M applications, there should be the interworking proxy in the middle, so they can talk to each other thanks to IPE. And since they are the non-one system, so the protocol or the interfaces would be different here and here. And the data models that they use and oneM2M is using are different. So basically IP converts the data model and the protocol or the API. And the conversion theoretically should be done in both ways, like the sensor reading should to go up to the platform, and then the other OneM2M applications can access to that. And OneM2M applications can send the actuation message to the actuator or controller over there, which is non-OneM2M system. So let's design a IPE. So the goal is you should be able to create your own IPE for your service in a specific technology. Like maybe you can extend the project that we are going to have in today, like the CP interworking or LoRa interworking by yourself. So there will be the procedure like, okay, what should I do with my LoRa interworking IPE? Well, what should I do with my own CP interworking IPE? And you should be able to design the kind of system, how it composed of for different devices, and how the resources are kind of working in my scenario, and so on. So in this example, for example, yeah, those two are represented as non-volatile device, just for the simplicity. And there is the IPE and the platform and the other oneM2M native application. So the assumption or the simple scenario would be the devices are kind of reporting the sensor reading, and of course it shall be given firstly to the IPE because they talk each other in their own language. In other words, the proprietary protocol. And IP has a role to kind of bridge word here and there. So he will kind of synchronize the new sensor reading to the oneM2M platform. And it will be done like the new resource creation or existing resource update. That's what IPE does in this. So the other applications can discover the devices because devices over there will be represented by a resource, whatever we chose by the design, and it should be done a priori by the IPE. So there will be the resources representing devices, the sensors and controllers, and the current kind of status of the device, and so on and so on. When you send the control message targeting a device, of course, the control message will be sent by the oneM2M application, and it will be targeting a resource which represents the control device, their kind of data container, whatever, on the CSC, and CSC will send the notification if we assume that the IPE already created the subscription for that controllable container, for example, like the idea or the scenario that we had in the day one, the app developer guide, then there will be the notification asynchronously transmitted from the CLC to the IP. And that one will be converted into their proprietary protocol, and there will be the command message in their language, and then that one of them device will be kind of do something. So that was the scenario. And again, everything is kind of resource in the platform, and they talk to the platform as a kind of intermediary or the broker, let me say. We need to design the tree. And for the data, for example, we can use container or you can use flex container. We've been using container a couple of times so far, but we have not yet used flex container. But don't worry, we will be using it for the Zigbee interworking. And especially for the proximal IoT network devices interworking, you can refer to the TS33, which is the interworking framework. And I can provide a very brief introduction what it is in day one. Basically, there are a list of guides. How do we kind of represent the non-oneM2M system into oneM2M? In this case, this will be the container. In this case, this will be AE, something like that. So please refer to that one. So this is the kind of procedure, ordinary procedure that we are going to apply to the IPE implementation. And you should notice that this is really similar to the procedure that we had for the application developer guide in day one. So there will be the registration, registering the IP itself as the AE, and registration for the non-oneM devices. So they can be discoverable by the other oneM applications, and they can store their data in their own resources for the registration. And we create some initial resources, and depending on the resource type, like the container or flex container, you will create something and you will put some kind of initial status data. And yeah, those will be kind of accessible by the other oneM2M applications. And for the IPE, to get some kind of real-time kind of event notifications, for example, for the actuator, the IP should subscribe to the corresponding resources, and then they will finally get the notification per event, and the IP will kind of translate the notification to actuate the non-oneM2M devices from their side. And later on, whenever there is a new data from the non-oneM2M system, it will be synchronized into the oneM2M resources already existing or as a new resource. And whenever there's a actuation message from oneM2M side, then it will be passed into the IPE and then be actuated in the non-oneM2M world. And yeah, something like that. So let's have a sample recipe. Nodian represents no device node, so basically non-oneM2M device. Let me say. So non-IP gets the other devices, non-oneM2M devices information and register them. And of course, he is registering himself to the platform also. And you can see the icons that I mapped from the previous figure into this kind of diagram flow. And the assumption here that we have is IPE as the software piece and the CSE as the kind of oneM2M platform. They are running on the gateway physical device, and it doesn't have to be, but this is just the kind of assumption. And there is the registration. Once they made the registration, we are creating the resources like that for all the AEs. An example, so please don't mind this is bulb 1 or 2. Anyways, we are creating the AE and then we create the kind of data sharing resources. That's what we mean by DSR, data sharing resources. Sorry for that. And then you will choose the type, and if you decide the container, then the IP will create the containers for the devices like this kind of sensor measurement data or the controllable actuation data and so on and so on. So the flow is again really similar to the application developer guide scenario that we had yesterday, and put some kind of latest sensor reading to those kind of resources. So we are creating these kind of initial resources under the application entities, which represents individual devices. And there should be the subscription for the real-time communication. And the IPE creates the subscription for the actuation of the device 1 and device 2, for example. Then whenever there is a new event, like the content instance creation or flex container update, then IP can get the event notification from the CSC, from the platform. And that event has initiated or originated by the oneM2M applications because they created the new command as a resource where they have kind of updated the command data synchronization. So if the user application creates some subscriptions to the data representing or sensor reading containers, whenever the non-oneM2M devices or the IP provides new data to those data resources, then there will be the notification targeting the user application, service application, which is oneM2M applications. That is the kind of real-time data retrieval as a kind of push from the platform. Of course, just like the application developer guide, we can leverage the group fan-out feature. So the user application can create a group for different kind of devices, and we don't create a group for the device if we wish to kind of control them all together or whatever. Normally, we group the resources that we are interested in, the sub-resources of the device representing resource, and we can get the latest status as we did for the day from the day one, and we can send the command once to actuate or to control multiple devices. And it's all the requests are gonna send targeting the platform because platform is providing those capabilities because of the group research that the oneM2M application created here. So that's the API, how it works. That's it for the interworking overview, and I hope you got the kind of essence of the interworking. How can we leverage the concepts from applicant developer guide towards sequence or procedures for the design? And we will kind of adopt this one to have the Zigbee interworking and LoRa interworking. Thank you.